In our last video, we colored a periodic table that looked like this, and we said that we were going to be able to use this periodic table to help us figure out electron configuration. In this video, that's what we're going to do. So we are going to be learning about electron configuration. And so what we're actually trying to do is we're trying to figure out how do we determine how many electrons are found in each orbital for a specific atom. So an electron configuration is like an address for the electrons in our atom. Each element has its own address because each element has a different, unique number of electrons. So we started talking about our atom. We said that the center of our atom was called the nucleus. And we said that that's where our positive protons and our negative electrons were going to be found. Well, our electrons are going to be in electron clouds or electron orbitals or electron shells, but they are going to be outside of the nucleus. Now, when we write an electron configuration, for each orbital, that address is going to have 3 parts, okay? So the first thing it's going to have is it's going to have a number. And that number represents an energy level. So when I'm looking at my orbitals, the orbital that is closest to the nucleus, I say has the lowest energy. This would be level 1. The next one is a little further out. It requires a little bit more energy, so it'd be energy level 2. Then we would go into energy level 3. The next one would be 4, 5, 6. So the number in front is telling me how far away from the nucleus I am. The bigger the number, the further away from the nucleus I am. Okay? After the number, I'm going to have a letter. The letter is going to be either S, P, D, or F. And that represents the shape of my electron. Remember, we said that S orbitals were shaped like a sphere, P orbitals were shaped like a dumbbell, D orbitals were shaped like a 4-leaf clover, and then F were weird. We weren't really concerned with those. Okay? Then, I'm going to have another number. This number is written as a superscript, so it's a little number up top, okay? And this number represents how many electrons that are found in that energy level in that electron orbital, okay? Now, I'm going to have to repeat this pattern. Number, letter, number, number, letter, number, number, letter, number, again and again and again until I have described where every single one of the electrons for my atom is found. Okay? So this is the process that I'm going to follow. I've got my periodic table. and I want to describe where all of the electrons are found for sodium. That means I have to write the address for 11 electrons, okay? So when I look at my periodic table, I'm going to read this as a book. I start from the upper left-hand corner. I read left to right until I finish the entire row, and then I start again at the next row. So left to right, left to right, left to right, moving from the top to the bottom, and I only stop once I hit the element that I'm trying to find. So here's the way I read this, okay? I always start in my upper left-hand corner. So my orbital energy level 1 is shaped like an S. It can hold 1, 2 electrons. So number, letter, number, the last one's raised as a superscript. So this is 1s with 2 electrons. Now remember, helium is actually found over here, but he's in the s orbital, but this has completed the entire first row. I keep going until I hit my element. So then I go on to the next row. The next row is energy level 2. It's still orbital S, and orbital S can hold 1, 2 electrons. Okay? I keep reading straight across. So now I hit energy level 2, still 2. This time my letter is P, and the p orbital can hold 1, 2, 3, 4, 5, 6 electrons. Okay? I still haven't hit my element. I haven't found sodium, so I keep going left to right until I get to the end, top to bottom. So now I'm on 3s. Now instead of keeping going, once I hit my element and I stop, so this is going to be 3s, I go up, there's only going to be 1 electron there. So if I've done this correctly, all of these superscripts should total the number of electrons for my atom. 2 plus 2 is 4, plus 6 is 10, plus 1 is 11. So I've shown where all 11 of sodium's electrons are going to live. Okay? Let's try this again. Let's look at bromine. Now bromine is even further down, so I have to go all the way to here. I need to find homes for 35 electrons. Okay? So just like I did with sodium, I start in the upper left-hand corner. Number, so this is my 1s orbital. And then I count blocks, 1, 2, so it can hold 2 electrons. That gets me all the way across. Now I'm on my 2s. I count blocks, 1, 2, so my 2s can hold 2 electrons. I keep reading across, 2p. I count blocks, 1, 2, 3, 4, 5, 6. My 2p can hold 6 electrons. That finishes this row. Move on to the next. 3s. My 3s can hold 2 electrons. I keep going across. 3p. My 3p can hold 1, 2, 3, 4, 5, 6 electrons. Keep going, that finishes this row. So now I'm down here, 4s. My 4s can hold 2 electrons. Now careful, even though this is a 4, my d orbitals start with 3. So I go 4, 3, 4. Be careful, the d orbitals are always one number lower than you would expect them to be. So I'm in the 3d. The 3d orbital can hold 10 electrons. I keep going, 4p. Now I only go until I hit my element. So bromines here, I go up. There will only be 5 electrons in that 4p orbital, okay? So if I did everything right, I should have 35 electrons. 2 plus 2 is 4, plus 6 is 10, 18, 20, 35. So I've described where all of those electrons are found, okay? Take a couple minutes and try to do, let's do nickel, okay? So if I was doing nickel, again, I always start at the beginning. So for nickel, 1s with 2 electrons. That finishes the first row. 2s with 2 electrons. 2p with 6 electrons. 3s with 2 electrons. 3p with 6 electrons. 4s with 2 electrons. Careful, 3d. I only go until I hit my element, so nickel is 8. If I did everything right, I should have 28 electrons. 2 plus 2 is 4, 10, 18, 28. So I found homes for all of those electrons, okay? Now you want to be very, very careful with your d orbitals. I go from 4 to 3 to 4, 5 to 4 to 5. The d orbitals are always going to be a little bit tricky because they'll be one number lower than the 2 that surround it, okay? F orbitals are even trickier. F orbitals fit in these boxes here. And when they fill up before the d orbital. So if I was here, I would do 6s2. I hit this open spot. So then it would be 4f14. And then I would do the d orbital. Down here, would do 7s2. Before I would do the d orbital, I'd come down here, 5f14, and then I'd go on to my 6d orbital, okay? This gets easier the more you practice. So we'll keep practicing in class. We'll do this more. Try your best.